Okay, good morning, everyone. Maybe just to can hear me, isn't it? Right. So let me do a quick one. So welcome to this last lecture, last session. Right. After this, we will go our separate ways. So maybe you are doing in your second sem and your whatever. Right. So before I start, so any questions again? No. So I think I tried. Okay. So I think I'll turn off the camera because it might slow down your network, right? So I will maybe I'll turn it on again towards the end of the lecture. Again, so I think this is the last. I think the numbers are not okay, just about slightly above half of you have turned up, right? So let's get started. You can hear me, right? Should be fine. Let's see. I'll turn on this. So now I think some of you asked me before, what about some of the tutorials? Here, we cover that, cover that. So this will be, let me get started, set up the hardware, and then we will get started. Okay, so what I'm going to do today is actually finish the last bit of this tutorial 9, as you can see. And then after that, maybe take some questions before we jump into the what do you call it, the revision of the topics that I've covered. So any questions, comments from the previous lecture on the support vector machines? If nothing, can hear me clearly. So we'll jump into the last a short tutorial. Basically, I think it's very simple. Let me see, 2 pages. Okay, I think I can do it here. Okay, so we want to talk about Pixie. The question is actually, I think the type of questions for the exam. So at the end of the day, we still want to see how we have learned and then what have you learned. So the type of questions would be somewhat, I'm sorry, I'm using the fuzzy term, somewhat similar to here. Of course, it won't be guided, right? Guided, for example, what is deep learning, right? And discuss the main motivations. So, so you have to look at this from a overall view. So you explain what it is, give examples. End of the day, you have to convince the examiner that you know the topic well. Of course, if you can show it very well, of course you get higher marks because this is a sort of an open book kind of question. So you have to convince the examiner that you know your stuff, right? So what is deep learning? I think this one, I think because again, this is also part, in a way, part of the advanced topics, which is not in book by Professor Michael Nevinsky's book. So this is because it's still, the area itself is still developing, right? It's still being developed, in new areas being found, and then what works, what doesn't work is also explained real time. So you can see a lot of work being done there. So in this case, we want to look at what is deep learning. So again, the definition can be found from the lecture notes. Of course, I think basically it's about deep learning is about what do you call it? Learning representations. So it's about highly complex, maybe highly complex networks, new networks that can learn high dimensional data. Right? So that's one way of explaining what it is. Now, question number 2, what it seems simple enough to say that a neural network is deep, right? You look at the term here, deep. Let me see, have I I haven't, right? I haven't. So I have presented this so you can see it. To make sure it's deep. Discuss why this can be difficult task to define or describe. I think this is actually also a bit of fuzzy, right? When you say deep, how deep is deep? Is one layer deep or 2 layers deep? Three, what is it? So again, there is no general consensus, general agreement on what is deep, right? So this is so you have to describe and explain why this can be a difficult task to define or to describe. Give me a minute. I need to do something first before I forget. I'm supposed to send you a survey form. Hang on, let me send it out first. Okay, maybe I'll do it during the sort of when we stop for a while to actually look at the when we pause and we stop after this and then go on to the next topic for that. Okay, I think I got it. So I got it here. Maybe I'll send it up this form. In a minute, I'll send up a form to you. Okay, right. So I got it. Right, and I'll send it out. Okay. Got it. Okay. Oh, sorry. No good. Let's do it again. It's the wrong date. Okay. Okay. Okay, got it. So you should see your this form being sent to you in a short while. Let me go back to the before itself, right? So the second part, so you have to explain. First of all, explain what you mean by deep neural network, and of course, try to explain how you actually overcome the problem, the challenge of saying how deep is deep with one hidden layer considered deep, right? And then so I think we discussed a little bit of this in the lecture notes, in the lecture itself. Now, question 3 is actually again, question 3, if you look at it, basically even question 2 itself can be tied back to question 1. So you have to explain what you mean by deep neural networks. So again, you talk about difficulty of saying how deep is deep. How do you classify? How do you say this is deep and the other one is not deep, right? And then of course you need to also give examples. So you can see this is a complete what do you call it? Complete description, right? To explain what is a deep neural networks or deep learning, right? So we give 3 types of, in this case, 3 types of deep neural networks. Okay, now question 4. I think we have only question 4. Okay, I think we should finish it within the next maybe half an hour or so. We then can jump straight to the revision. Now for this one, let me see. Okay, now what is the, first of all, it sort of checks, it asks, it examines your understanding of the how to calculate the output from this what you call this filter, right? In 4A, question 4A, right? So how do you actually get the output using this filter on this pattern, on this image if you like, right? So you have to, then you have two cases here. First case is a strike of 1, and then the second one is a strike of 2. So again, it's a test of understanding what you mean by strike of 1 and what you mean by strike of 2. Yeah? So again, this is something we should be able to do. Okay, now look at the first one. Now, let's try the first bit, that is the output. Output of the first bit. Anyone want to try? Again, this is basically to this tutorial is to what do you call it, to complement, right? Complement the lecture so that this will give you a deeper understanding of the topic itself. Let's see, who can I invite? Christopher, are you here today? Let me see if Christopher here today. I don't see him here. Maybe he's here. Who wants to try? Yan Chang, want to give it a shot, right? So maybe I'll help you. I think Yao Xing has the line has dropped. Okay, so now if you have it here, okay, line is okay. This is okay. It's okay. Okay, now if you have it here, the strike of 1. So let's start with the first processing. So this one's over here, right? You have to fit the right window, right? So can you set the right window? So who can I ask? Yao Xing's line is still very bad. Still drop. Yan Zhang, are you there? Want to try? What is the output when you apply the first time round for this filter, convolution filter, as shown here on the left hand side, on this pattern here on the right hand side? Supian, want to try? Yan Chang seems lost him. He's not around. Yes, correct. Yeah. So you can see here. Now, how the rest of you, do you know how they got the answer? Okay. Keep it simple for you guys. If you are shy to say anything, shy to say that you don't know, right? Just click on the little icon, the hand icon, to say that I don't really know how they got the answer, and then I'll explain. Otherwise, I assume the whole class knows. I saw something. Okay, right. So basically, you apply this filter onto this area, right? So it's a 3 by 3, right? So you can see here. So you basically multiply. So the first one is this one multiplied by this one. So you get a -1. So -1 times your 1. Basically, you need to multiply all of them. But of course, I'm a bit shortcut or lazy. I avoid taking the zeros, right? So this one, 0 times whatever I know is a 0, right? So I'm only looking at this particular space here, right? The rest 0, right? 0 times 1, 0. 0 times -1, you get a 0. Samuel, okay? So that's why if you look at it, sorry, David, not Samuel, sorry, Samuel. So what do you have? Then you have another one, which is here, right? A 1 times 1. And finally, the -1, right? Times your 1. So you get your -1 plus 1 minus 1. Kind of understand. Zhongyang, what do you mean kind of understand? You should understand, kind of understand. Okay, maybe let me ask you the other way. When you say kind of understand, it's a fuzzy term. Just so there's something you still understand. Explain further for me so that I can explain back to you. So that it's now you fully understand, not to say kind of understand. Would it be all right? So I actually can see I'm a bit picky here. over the language. So when they say kind of understand, means it's something you're still troubling you or bothering you. Maybe I think I know some lecturers do this, but I don't do this because I don't do it for the right part, right as in right hand side or what. I don't do this because it will slow down the what I call the network. But again, let me try again for this last lecture. Especially if I'm working from home. If I do that, the network will actually slow down tremendously. Let me see upper right. What do you mean right part? Upper right 3x3. So you have to explain to me what it means. You can see my difficulty. This is I'll come back to this later on. So we say upper right 3x3. Upper right 3x3. Anyone help me with that? Anyone can help me to interpret what Chong Yang is trying to explain? I think yesterday was it. Upper right 3x3. Upper right is here. Upper right is here, right? Upper right 3x3. This one is it? Just want to see how it calculates. Sorry, I still don't understand what you're asking, right? So basically, maybe I'll erase this. Try start again. At any time the network is slowing on your side, let me know. I'll turn off my camera so that at least it don't slow down, especially with lagging. So first time round is I take this. This is my convolution filter. Now this is actually very relevant, very important, especially if you're using deep learning in your FYP. I think many of you are doing that, and I see that some of you, not all of you, at least in the past, treat this as a black box, as just a magical tool that you throw in something, it will give you the right answer. Right? Unfortunately, it's not that way. So what happens is that you may end up with very lousy results. It doesn't work. It gets you accuracy of less than 50%, 20, 30% accuracy. Right? So in that case, you have to try and debug. When you debug, you have to understand the theory behind that. Right? So it's good for you to actually try to follow. So in this case, I have this same thing transferred over here. So when I transfer over here, I get this. Maybe use a different color. Use a blue color, striking. Okay. So back here. See that, Chong Yang? Anyone else? So let's try to help each other. Right? I'm trying to explain. If you think I don't explain very well, apologize, of course. And of course, I will try to explain better. Right? So in this case, so the question is, you have this filter processing this image or this pattern. So the first time you treat it as the left-hand side. Again, right? This is an issue of what do you call that? Your how you want to do it. I can start from left-hand side. I can start from right-hand side. I can work this way. I can also work this way, right? But I'm just that for convenience. I'm always start from left-hand side, especially when you read things in the English language. Right? It's always from here to here, not from right to left. So of course, there's nothing to say that you can't do that. Right? So in this case, Chong Yang, can you follow so far? So now so the task, leave it, okay? So the task is actually you multiply this fella, the same spot, because this filter is now superimposed upon this pattern, right? This one against this one. So what I get? -1 and a 1 here. The next one will be, I can treat this one. 1 and now what is it? 0. The last one will be -1 and a 0. Right? And then you continue doing it. So you add up everything. Plus your 0, -1, plus this fella, 1 and 1, plus your 0 and -1. And finally, the same thing here. Chong Yang, okay. Okay, that's why we got minus 1 plus 1 minus 1 plus 5, get a minus 1, right? So that's how you actually go about doing it. Okay. Now to test the understanding, I will invite some more of you to actually try the next one. Let me just erase this to clean up the space. So I got a minus 1. Now, next question is, how do I move? Do I move? Of course, I move to the left, right? So how do I move? Do I jump into here, or do I jump just here? So this one is since we are doing a swipe of 1, so just only move one cell to the right to process. Basically, you need to process, right? You need to process all the whole image, right? So in a way, actually, correct. I was saying just one cell because it's a swipe of 1. And again, as I mentioned before, why right and not left? Right, left is nothing here. So this one is by basically when you program it, when you write the code, so you choose to move to the right. You start from here. I can also start from here, but end of the day, it doesn't really matter, right? So now next one, what's the answer? Chong-yang, want to try to see whether you truly understand? So what's the next one? Or David, want to try? Okay, huh? Is it minus 1? Let me see. So we have this cell here, swipe of 1. So actually, previously was here, right? This cell. So now here I get this one will be minus 1. All right. This one will be a 1. And the last one here will be minus 1. So you still get a minus 1. Right? So David, that's correct. Now the next one now. So you continue doing that. You continue doing that. So you can see actually it's very simple. This one is so simple. So actually if it comes out in the exam, of course you will do very well. So now the third one. So I can see here, this is a minus 1. This is here will be also a minus 1. Here will be a 1. So you still get a minus 1. Right? And then, oh, sorry. The last one here. The last one here. So sorry, Chong-yang, I didn't get the what I call your question. So that one I miss here. We have to look at it. Let's look at it, and then after processing it, you will see whether it's a 4x4 or what. So this is a 4x4 because you need to move. So we can see actually it's a what's the number for this? It's a compression that you are trying to reduce the size of your initial image into like Chong-yang has said is a 4x4 because of the strike of 1, right? So again, as an engineer, what does it mean? Need to put Yao Sheng, what do you mean by original? Because you are trying to process this part, right? And again, we are only doing for a simple example, which is will not happen in real life, which is too simple. This is what this is a 2, 4, 6, 6 by 6. Now you tell me, what is the size of an typical image? How big is it? Smallest one will be maybe 500 by 500. Okay, so if I have such a big image, and for you to process, right? So if you can reduce it, it'll be faster as well. One of the advantages of that, I think we did discuss that. Okay, this is part of the work of actually the what's that word? The filter itself, the kernel. The word I'm looking for is kernel, because we just finished that, right? The kernel to actually reduce that. Of course, you can also apply. Later on top of this, you can apply many times. But the key thing is that when you apply many times, what happens? It takes more computing power, in the calculations. So you can see this only works when you're able to get both fast and cheap, I suppose, cheap computing power, right? Because if you unable to get buy the computer cheaply, right? I think not many people will be able to do that. So that's why because of the cheap computing power and also powerful, right? You can buy a very fast processor of PC to do the work. So therefore, many of us are able to use that in our work, in our research. Okay. So the last one will be what? Let me see. Okay, David, last one. What's the? Oh, I asked you before, dear. Who else? Sorry, David. Shouldn't ask you too many times. Rian. -1, is it? The last one, -1. Let me check what I get. Okay, -1, right? So now what happens? I finish this particular first block. So now I also move the next block. So it's a 3 by 3 again, right? And that's what Yao Xing pointed out, right? Or is it Yao Xing? Or is it who was it? We'll talk about 4 by 4. Okay. Chong Yang talk about 4 by 4. The next one. So, okay. So this will be a still -1. Next one, -1. Now, this one, siapa lagi? Ying Han, if you are here, you try the next one. Here, this one. So it's a 3, 1. So I think it's this block. Yep. And Chang, thank you. -2, is it? Rest of you, can you get -2? If you get a different answer, we can always discuss, right? So I just want you to try. Once you try, you find it. It's like riding a bicycle. The more you practice, the better it is. That's why same with footballers and other things as well. Let me see, erase this. Right, so this one is -2, right? So last, this one here, over here, want to try? So this one will be what? Yao Xing, yes, correct. This is a 1 now. And you do the same thing, you proceed, right? So after this one, the next one is here. And finally, one more here. That's why you end up with 4 by 4. Now, what's the answer? Let's give the answer. And let's erase this. How the network? It's okay. Can I still maintain my video camera so that you all can focus a bit? I know it's I find it's useful. At least you can see the lecturer. You can focus. Otherwise, it's just a letter on the screen, right? I don't do that because especially if I'm working from home, the network tend to lag very badly, right? So we get these answers, right? So can you get the answers here? So we get the answers here. Just any comments, any questions, any comments? I'm gonna make it. Right. So we got that done. Now, next one. Erase this. Any questions on this before I erase it? Okay, I erase this. Now, what about strike of 2? So we still have back the same answer, -1. What is the next one? 62, about 28 of, 62 minus 3, 59, 59, 90, 1, 40, no, 20 plus of you, right? Missing, still, I think maybe have other things to do, right? Function. Yo, think want to try? Next one. Here, what's the answer here? The next one, what's the value here? I process this. -1. Is it -1? The rest of you? Let me check my answer. Okay, it's -1. David, you know you got -1. Sure. Okay. Okay, since you see you know how to do it, how about here? This one. David, try this. What's the answer?
I know you moved 2 books to the right, but then after that, should I go down or? Hello? Hello?
No. Anyone else? What's help out so that I can speed up the process? Otherwise, I'm afraid we cannot finish the rest of the today's. No. Have we finished? 3 is here. First one is here, isn't it? So, sorry. So the question will be, what will we get? Will we still get a 4x4 or we get something not 4x4, 3x3, for example, or first, just now we get 4x4, which is from strike of 1. Now do we get, what do we get? A, B, C. Dennis, what do you think? A, B, C. So easy for you. I pick C. Okay, I got an A, I got a C, and I get a A. Okay. Wait, I think I would tend to agree because you see, what I'm trying to ask is actually, what do you mean by strike 2? David, I'm still waiting for the answer. David, strike of 2, is it? So basically, if you can understand what's the strike of 2, you'll be able to answer this. Correct. Chong Yang, correct. You shift the 2. So if I do that here, so you can see lectures, we don't have time to actually go so slowly, right? To explain some of these calculations. So, but now we can. So now if I could draw this out with a different color, you can see better. So I just now was strike of 1, now strike of 2. So basically I shift this by 2. That's how I think early on I got the -1 here. So this will be -1, 1 and -1. So it's like -1 here. Now this one now, the last one here. Let's say I take a red color perhaps, right? So we shift by 2, I get this. Dennis. Is it Dennis? Yeah, Dennis. So what happens now? Do I move down or is it invalid? Anyone? Get your brain cells working. Right? Chong Yang suggested we move down. But this is something we invalid then move down. Okay, we went, right? So this is something I think we don't have time to actually discuss this in the class, in the lectures. This is more of the operation issues, how you process such information. There are, of course, various ways of doing that. Basically, they actually do some padding. What happens if you do some padding is you actually pad this with zeros. Because why? It cannot fit, right? It cannot fit. Samuel, right? Good. Okay. It's okay. Whether right or wrong doesn't matter. We are here to discuss this to make sure you understand. So basically, you pad this with zeros, right? So of course, now question. Okay, then I'll come to that later on. So this one is padding. So once you have that, what you have, you still have this. So this is a 1 times a 1. This one will be a plus minus 1 and a 1. Anything else? No more. So I get the 0. Right? Does that make sense? Any one of you? The class is about 62 of you, right? 62 of you. So then it's that. So the rest of you, do you follow? I think you see my problem here. Actually, it's not easy to lecture during this time. So I don't know whether you know or not. You just people say yes and you follow. Okay, good, you follow. So now, next question. Since you all can follow, yes. So we get a 3 by 3. No, wait. Maybe we earn. Maybe 3 by 3 or something else. Let me ask you a question. I like this kind of question to get you to think a bit. Can I do this? Can I do this? And what color do I want? Purple. Purple, right? This is strike of 2, right? Strike of 2. So now do I do another one here? Correct. Right? That's why you stop. Right? So that's why you go down to the next level. Now, how do you go down? You still correct. It's not a waste. It doesn't make sense because there's nothing here, right? If you still going, if you do that, what happens? I can go forever, right? So it's a waste of time, which is correct. So now what happens? Now do I move again? I move 2 strikes down, 2 cells down. Right? So again, you process. That's how you get the answer. So basically, you end up with, and then the last one, of course, there'll be another one here. There'll be another one here. So you can see, sometimes these kind of things will come about when you actually discuss it, right? In the tutorial. So last one will be here, right? So again, this is I'm putting the last one. So the last one will be here. So again, you do some padding. At least padding over here, right? So again, that's how you process it together. That's why I end up with a 3 by 3. Follow? Now, but close to 10:45. I need to quickly finish this. So what do I get? I get this is what I get. Check again. So this one is minus 2, and then finally you get a 0, minus 3, minus 2. Right? I believe there are maybe some other different ways of processing when you have this when the thing doesn't fit nicely. But basically, I think I've seen many people use padding, pad it with zeros, so that you get this. So you get a 3 by 3 when you have a strike of 2, right? Okay. Right. Any questions before I move to the next part of the question? Okay. So this is done. So now describe what is a convolution neural network. So this one talks about I think this one I won't spend time doing this. We discuss it in the lecture. So go back to that lecture on the convolutional neural net, right? How does the architecture look like? What are the convolutional layers involved in that? What are they good at? Right? So we have to describe about that as well. So now, what are the what are the processes here? Can someone still remember what are the some of these processes? Right, you have your input layer, right? And then what happens? What are the next part? What do you do? You do convolution. It's what is seen here. It's where you compress it. You convolute. So you have a convolution layer. convolution layer. Basically using some of these techniques here, some of these filters, convolutional or kernels. Kernels. What else? Then you do your, anyone? What's the next process? One of the, I would say, process, a typical process for a convolutional neural net. Let me see. Only want to try? Correct. Pooling, right? And this is pretty standard now. Now after this, what happens? Lawrence? What happens after this? Do I stop? Yes and no. Junhao, I'll come back to it later. You're not wrong. You're also correct. But I want to say, Lawrence, what do you think? Do you agree with, what was it? Junhao to flatten, or do I do something else? So again, this one is more of a operational issue when you actually design your network to do something. So Junhao talk about convolution, pooling, and then flattening. Lawrence, what do you think? Not around. Brenda, are you here this morning? Brenda. Oh, here is it? Brenda, not here. Who else want to try? Yep. So I think Wing Liang, thank you. So what do you see? We can keep repeating this many times until you're happy. You try it out. So of course, if you do it one round, you find that it's not so effective. So you can repeat this X number of times, right? Many times. And then before you finally flatten it. Now, after flattening it, what happens? After you flatten, what happens? Then you pass it to your neural network, right? Remember, we talked about this before, right? So we actually all these processes, and then finally you flatten it, and then you pass it to maybe the MLP, right, to process it, to actually classify it, right? Okay. So now the last question here. This is very simple, right? So let me see who will have the honor. Many more. Li Yi, Ong Li Yi, maybe you can try. What do you think the so this is after flattening the following pattern. So this one actually there's one layer behind this. So actually I'm showing it here. Is it 1 or 3? 1, is it? Let me see here. 1, is it? Junhao, what do you think? What do you think is the answer? This one there's no one correct answer, right? So can be many correct, right? So you see basically you flatten it. So he Li choose to flatten it as 3. So we put it this way, 3103. So we put it this way, right? And then the next one will be, so he right, so we get that, stretch it up. That's 1, 1, 0, 3. Now we have to draw this out. 4, 8, isn't it? 8, So I have 1, 2, 3, 4, 5, 6, 7, 8. Let's say I give it to 4 layers. So 1 layer consisting of 4 neurons. So 2, 1, 2, 3, 4, 5. You can see it's getting difficult to draw, right? and it goes up. And the last one over here. Let's say I want another three neurons here in the next layer, right? Maybe I stop here, right? So these are outputs, Q1, Q2, and Q3. Okay, any questions? Oops. Right, so we completed this. Anything? No more. So we completed this very quick and very, I think, easy tutorial on the deep learning. We look at the two processes, which is convolution, and then the other one is flattening. We did not do, maybe I should do it next time, max pooling. Max pooling. Maybe I can do it here, right? So now, okay, now maybe I can do it here. I forgot about this max pooling. I shall also include that next time. Okay, so now let's say we have this. If I want to do a max pooling, right, of 2 by 2. Max pooling of 2 by 2. So I will process this. So what do I get? So you can see max pooling actually will be it will actually reduce it further, right? So what's the output for this? If I do a max pooling, so this one text will understand. Eugene, what do you think? What will I get if I do a max pooling of 2 by 2, 2 by 2 kernel? Eugene? -1. Hey, okay, good. At least understand. So you basically within this window, you try to find the largest value, which is, you can see here, it's -1. Now, if I use back the same concept of a strike 1, what happens next? I do another one here. Yeah? So I get a 0. I move down 1, I get another 0. And the last one will be -2. This is short. That's pooling. Actually, I think we didn't discuss here. Actually, there's a convolution pooling. That's why you see pooling here. We talk about this, right? Is that all right? So looks like we come to the end of this tutorial. Any questions before I stop here? No? Okay. So I will stop here and then we move on to, do you want to take a break or do I continue? Oops. Okay, let's take a 5-minute break and then we'll come back and then I'll do the revision. Okay? Short one, 5-minute break. Okay, I'll start soon. Don't worry. I need to print out the QR code for our office. Okay, I think we should be starting. I think okay, I'm done. It's done. Okay, let's start the revision. Now, what I will do is I will go through all the major topics. So that is the way we'll do this revision. Of course, please ask me any questions if you're halfway through, if I can, something you're not clear, something that's been bugging you for a while, and it was a good thing to ask, the last chance. Now, maybe I can just point out something here. I put up the sign here. So this is the ranking of the universities, I think, for the whole of Malaysia. And I think we actually, of course, there are various categories. You can see here, we've got a 5-star out of 6, possible maximum of 6 stars. So we've got 5 stars out of 6 stars of the university college category. So I mean, we do quite well in terms of the ranking for that class, which is university colleges. So we got 5 stars or 6 stars for 2019. So we are not too bad. You see, it's not too bad. And we've got a ranking of, we have all the processes, the system in place to actually support the teaching and learning. So let's look at this particular revision. Let's go through this in the next 1 hour or so. So this is the syllabus. Roughly, maybe may not be in the correct order, but this is what we have looked at. So we are looking at the first one is the introduction to maybe some of the motivation of artificial intelligence. Now, in the old days, maybe before 2013, for example, right? 2013 or maybe even 2015, when AI is not that hot. So some of you need to be convinced that why AI is so important in our life, especially in the years to come, right? So in that sense, it gives you we talk about some of the motivation, we talk about some of the advantages, we also talk about some of the challenges of AI, and also what AI hopes to achieve, right? In that area, how can AI help industry and also in general humankind? Now, before I forget, in case I might forget to look at the chat box once in a while. So if you have any urgent questions, please stop me and then just maybe turn on your mic. So then we move on after the short introduction to AI, talk about the what is intelligence, right? And then if you want to build artificial intelligence, a system that is intelligent, artificial, right? Why? Of course, we need to understand why do we want to do that, because no, it's not easy to become expert, right? To become a expert in to do certain things. So of course, we want to have access to that expert, maybe even 24/7. Every hour, I want access to that expert. So what better way to do that to actually develop an artificial system that is similar to the expert in that field. So I can then tap into the expert's knowledge. So that's why one of the motivations of doing that. Now, if you look at it, if I want to do that, I need to be able to measure. Have I been able to develop such an intelligent system? So how intelligent is my artificial system? So for that, we need to be able to measure. And then we saw that it's not that easy to measure intelligence. So there was the initial discussion on artificial intelligence. The first topic after that, we can jump straight to some of the major topics in the field of artificial intelligence, which is search. So we're looking at search as a problem-solving tool, right? And that one actually we look at, we have about 2 weeks of lectures on that, looking at the search in general, and then we look at what we mean by informed and uninformed searches. We did not go into some of the more powerful search techniques. For example, I think this was introduced to you unintentionally during your lab practical, right? You're supposed to just use it as a tool without really knowing whether it is a GA, genetic algorithm, or something else. So it's for you to compare the simpler search techniques of the random search and also the nearest neighbor search. Right, those are very simple, and it's also for you to be introduced to the concept. Then, of course, how powerful are those search techniques? They're very fast, but how powerful, how good are they? That's why that's why I wanted you to compare against this more advanced, more powerful search, which is actually built from genetic algorithm, right? And I think some of you put effort to actually understand that it's actually based on the genetic algorithm. Then we then went on to look at expert systems. We look at expert, how to define expert. Then we look at how to represent knowledge, right? And then from that representation, I can then use my expert system to do reasoning. So the next topic, we actually went on to actually look at the representation of knowledge and also the reasoning with uncertain knowledge. So we actually studied 2 methods, which is based on the Bayesian rule or Bayesian reasoning. And then another one, because of the limitations of the Bayesian learning, we also then went on to explore uncertainty theorem or uncertainty way of reasoning to actually overcome some of the weaknesses of your Bayesian reasoning. Then from that, we will gently introduce into fuzzy logic. So this one covers about maybe 3 weeks of lectures. Look at what is fuzzy logic. And then we look at the fuzzification and the fuzzification methods, how to fuzzify, how to build a fuzzy inference system. And then look at the various types of the 2 main types, which is the Mandani and also the Sugeno method of the fuzzification. And I think from the previous years of teaching students, I find that this topic here is relatively simpler for students to understand, and most of you can actually do quite well when you come across questions related to fuzzy inference systems. Then we spend the next maybe 4 weeks or so looking into artificial neural networks. Again, if you look at it, we always started with the motivation. Why we wanted to develop this system called artificial neural networks. We started off with the very simple artificial neural network. This is just based on a single perceptron, a single processor, or a single neuron, which is known as your perceptron. Now, because of the limitations of your single layer perceptron or the single neuron, then there was some work done to develop the multi-layer perceptron, because your single neuron, if you remember, can only handle linear separation, right? Linearly, right? If the problem space can be linearly separated, your perceptron can do it. But if the problem space cannot be linearly separated or not linearly separable, then of course your single perceptron cannot handle that. That's why there was a motivation to develop the multi-layer perceptron, multi-layer now, and then using the backpropagation algorithm to train the multi-layer perceptron network. And there's one type, which is the MLP is a representation of one type of your neural network, which is feed-forward type. Another major class is your recurrent networks. Now, in your recurrent networks, we learned that actually now the networks have feedbacks compared to the earlier one. The MLP doesn't have feedbacks; only go one way, right? But the recurrent, there's now a feedback connecting the outputs from the back to the inputs. And one example of which we studied in quite detail, was your Hopfield net, which is an example of your recurrent networks. Now, one of the reasons why we studied Hopfield net is because, remember, the field of neural networks actually almost died in the I think 60s or 70s, almost died because there was a criticism that is not able to handle non-linearly separable problem space. Right? If the problem space cannot be linearly separated, it actually cannot be used. So there was a major criticism on the artificial neural network, and only when the John Hopfield came along, and then actually he and David Tang suggested that there's some advantage of using Hopfield nets, and then can still do something useful. That's why there was a resurgence. They actually changed the direction of artificial neural network research. And lately, I think in the past maybe 5-6 years, there was a big interest in actually looking at deeper networks, not just one hidden layer, but many hidden layers. So there was the introduction to deep learning and CNN, convolutional neural networks. Now, the last two topics here are the advanced topics. That is actually many of the advanced topics, of course. So I think we actually look at two, which is quite popular and common in the artificial intelligence community or the world of AI, which is support vector machines. And support vector machines, I think we just finished it last 2 weeks. I finished a lecture on support vector machines, and we see how the support vector machines work and what are the things you can do with it, and how they actually do the calculations for the support vector machines. And the other topic that we actually jumped into was the swarm intelligence. This is the, if you like, artificial intelligence based on simple living things. If I say that, for example, the birds, the fish, and then you have also other types of ants and bees and other things, bats and other things. So those are the example of your swarm intelligence. So in effect, what have we learned so far? We learned 1, 2, 3, 4, 5, 6, 7, 8, about 8 different tools that can be used. That is actually quite common and has shown good results in the field of artificial intelligence. So that is the basically a quick rundown, a quick summary of your syllabus that was covered in the past 13 weeks or so in this semester. Any questions, comments so far before I go on to the next part? So this is the one I think I talked about this learning outcomes. So for the first part, the introduction to AI, what does it mean to call a system intelligent? Can the machine be intelligent? Can the machine be conscious? Right. So this was the I think things we have talked about. This is a summary. I think this was the tutorial based on that first topic on introduction to artificial intelligence. So the next part was actually on the introduction to search. Search as a problem-solving tool. So we look at the problem-solving agents. We look at problems formulation. We look at example problems. What are the problems that actually involve search, and then some of the very simple, basic search algorithms. And then we actually tie that back with a very interesting and very difficult problem, which is your traveling salesperson problem, or TSP for short. So the tutorial that we actually try to look at as an example for you to test, for you to understand better the search methods is your this problem here. For example, here in this figure 1, this figure here, right, it represents the city road map where the junctions are located on a 2-dimensional space, right? In this 2-dimensional space, and each is 1 kilometer. Okay, so we are supposed to find the way, right? Find the shortest way, effective, efficient way from S to G. So using, for example, the nearest neighbor method. So the lines represent the connection. So we cannot go from S to L. You have to go from S to N, N to L, for example. Then we actually spend some time looking at this and how to solve this problem using your nearest neighbor. I think we also spend some time looking at this from the bi-directional search, right? If you were to try that from both ends, can that find you a better answer, right? And here also we find that we show that there are certain limitations to your nearest neighbor method, because you can see here, if you take this as your first stop, it can end up with a dead end, either M or I, right? If it's a dead end, it's nowhere near to your destination on G. So therefore, we understand, we show that there was some limitations, weaknesses to your nearest neighbor method, right? So of course, what's the alternative? The best way, of course, is to try every possible combination, right, to find the way. But as I said a few times before, when the problem space itself is small, it's okay. You can try every single combination. But when the problem space itself is large, you find that it takes too long. Now, even for our lab practical, right, even for 16 cities, I tried it on a program to run it, test out all the possible combinations. Then I find that I have to stop after 10 days. Because why? From the theoretical point of view, if you to calculate all the possible combinations, even if you take 1 second to try out one combination, one possible solution, right? If you were to try out for all the combinations for 16 cities, it will take you a few years, even for a fast machine. That's why the thing just was not able to come up with an answer, even after several weeks, several days when I run it on the PC over here. So another one is an example here is this is question 4 taken from the 2015 exam. So this is actually asking, solving this from, this is basically a TSP to show how Kevin computes the answer, right? As opposed to, so Michael Jackson is the distribution manager for Old Town White Coffee, a leading supplier of coffee-based products in Malaysia and the world. So he has hired a fresh graduate, Kevin Lau, to manage the company's sales and to help distribute the company's products. So basically, Kevin has to collect the products ordered by the customers from the office warehouse in Shah Alam. So we start from Shah Alam, and they're supposed to visit all the cities, all the customers only once. And of course, you need to come back to your Shah Alam warehouse. So how do you find the answer? The shortest route, or shortest route for Kevin, right, to distribute the products to his customers in Lumut, Teluk Gong, Bentong, Alugacha, for example. This one actually is quite simple to calculate if you know the theory, right? So this one gives about 10 marks to actually show the calculations of how you do that. So any questions on this? So then we went on to the next topic, which is on the expert systems. So into what's the learning outcome for these expert systems is to, first of all, we look at what is knowledge. And then we actually went on to understand, appreciate that rules can be used as a knowledge representation technique, right? Using rules to represent a certain knowledge, a certain amount of knowledge. Now, then we look at if you were to form a team to develop an expert system, who are the main players, right? We have the manager, we have the knowledge engineer, then we have the software developer, then we have also the customer. Right? Those are the main players. Talk about this in the lecture on the expert system, and especially on the development team. Now, then we also went on to actually look at it closely. Now, if you were to build a rule-based expert system, because rule-based, right? Because rules were used, right? If and then, the antecedent and your consequent, right? Two parts. The if part and the then part to represent knowledge. If the sky is cloudy, then take umbrella, right? If the traffic light is red, then you stop, right? So this is your representation of your knowledge. So you ask an expert, right? What happens if my car cannot start? So tell you that maybe you look for the battery. If the battery is flat, right, of course your car cannot start, right? If the car starter motor is making funny sounds, strange sounds, then you check your starter motor. So those are the examples of how you actually consult the expert to form the rules to represent the expert's knowledge. So we then look at what are the structure of your rule-based expert system. Then we also look at some of the characteristics of an expert system. Then we look at the two methods in expert system, which is called forward chaining and backward chaining. Now, in the expert system, sometimes you have rules which actually seem to contribute towards conflict, right? One rule say that you should go when you see a green light. Another rule say that you should stop when you see a green light. So how do you resolve such conflicts when the two rules seem to be at odds, right? The two rules do not seem to agree on the outcome of that action or of that event. If the traffic light is green, you stop. Traffic light is green, you go. So which is correct? So we look at how do you handle such conflicts. So these are I think the tutorial on the expert systems. I won't spend time looking at it. And we have this is an example of looking at the expert system. How do you form the forward chaining and the construct the inference chain from these four rules. I think we spent some time looking at it. And from what I understand, it's quite simple. I think most of you can understand how to actually construct the inference chains based on these four rules. So this was actually based on the previous year's exam. For example, identify the correct animal from the forward chaining method based on the following facts using the 15 rules. There we go. So we are given this set of rules. So we have to figure out what is from these rules, figure out what animal are we talking about. So this one you use your forward chaining process or technique to find out what's the answer to that. So then we went on to look at uncertainty in expert systems. How do you handle uncertainty? We at least take a step back and revisit some of the basic probability theory. What do you mean by probability? Right? What's the probability of a coin turning up with a head? What's the probability of a coin turning up a tail, for example? Then we went on to look in quite detail, spend some time looking at the Bayesian reasoning. And then, of course, the Bayesian reasoning is not perfect. There are some biases of the Bayesian method, and these are some of the limitations of the Bayesian method. So therefore, someone came along and proposed the certainty factors theory as a better method to overcome some of the weaknesses of your Bayesian reasoning method. So the certainty factors theory and your evidential reasoning based on the certainty of that event, based on evidence. So this was, I think, last year. There was this question in the exam. Major Wong, an intelligence officer with the Malaysian Royal Police, received a telephone call from the public. So we labeled this public as a public, and that there was a major public disturbance in the Masjid India area of Kuala Lumpur. Now, before he orders his men to investigate, right? Since he's an officer, he has to send his men, police, to investigate whether there is a major disturbance in Kuala Lumpur, right? So he consulted the intelligent fake news filter. So there's a system called the intelligent fake news filter that the Royal Police has developed together with experts from Tunku Abdul Rahman's Faculty of Engineering and Technology. This system is called IYAPI. Right? Now, IYAPI has proven to be very reliable, right, in separating the real news from the fake news for the past few years. So Major Wong relies on the following set of rules based on certain factors to determine its next course of action. So, Major Wong has to look at this. These are his three rules. If the public information, the telephone call from the public is true, then news is true with a certainty factor of 0.5. Rule number two, if IYAPI, the system now, the intelligent fake news system or filter is true, then the news so you rely on two sources of information. One is your artificial system, the other is the actual information from the public. In this case, you can see that he believes a lot on your the artificial system, which is your IYAPI, and this one has a certainty factor of 0.9. So if the news is true, right, then disturbance is also true, right? So actually, if these two comes up to be true, then of course you believe that there's a real disturbance happening in Kuala Lumpur. Then you should send your man over there, right? That's how we calculate it. I think we have something similar. We actually calculated this in the tutorial. So this one I won't spend time to go again. So you can try it out. So it's actually quite similar to the tutorial you've done before. This one actually, okay. You can see here, based on the certainty factor, you find that it's a 0.95. Then this is on the parallel combination, and the formula is given in the appendix, right? In the piece of paper that has all the equations given. Then once you calculate the parallel combination, then you calculate your serial combination, and you come at 0.94. Now 0.94, your threshold. See, the threshold is 0.6, right? So the answer is 0.94. So 0.94 is higher than 0.6. So conclusion is Major Wong should send his men to Masjid India. Now, in the next part, we talk about this. Now, the machine itself, the expert system, the fake news expert system is broken. So therefore, rule number 2, there's nothing there. You cannot rely on rule number 2. So you only have rule number 1 and rule number 3. So therefore, what happens? Once that happens, you find that there's only this part left. So you have this. So if the machine is not working, so you find that the answer now is only 0.495. So since 0.495 is less than 0.6, therefore, if Major Wong can still rely on that, so Major Wong should not send his men to the Kuala Lumpur area to investigate the disturbance. Because of this, machine is broken. So this is on the Bayesian rule. And then we talk about Bayesian rule, and this is actually taken from the taken from the tutorial. So right, and so we talk about this in the tutorial about this disease meningitis causing 70% of the patients that have a stiff neck. Furthermore, we also know that the chance of a person to have a disease of meningitis is very small, right? 1 for 50,000, while there is only 1% of the people who have a stiff neck. Disease is so small, but the chance of a person having a stiff neck is higher, right? So calculate the percentage of patients that have stiff neck also have meningitis. So we use your Bayesian rule to do that, to calculate that. Now, we also want to look at the comparison, the strength and the weaknesses of your Bayesian versus the factors. So again, this was extracted from the lectures. So then we move on to the next topic, which is on the fuzzy system, fuzzy rules. So we started off with what is fuzzy thinking. And then we look at what are the common fuzzy sets, union, interference, the null, the what you call it, we have covered everything. So we have union, intersection, and so on and so forth. So we have also, then we look at what we mean by linguistic variables, and then we studied also some of the hedges to actually refine, your linguistic variables. Instead of saying that tall, we have things like very tall, and then we have very, very tall. On the other hand, you can tell as not so tall, right? Somewhat tall and not tall, right? This is an example of the different hedges. Then we look at how does the fuzzy set operate on your variables. What happens when you have a union between two variables, and also intersection of two variables. Then look at the fuzzy rules. How do you actually formulate fuzzy rules? So this one, I think we look at this based on this. We have three fuzzy sets A, B, and C, and then we study what the various types of fuzzy set operations. These fuzzy set operations are given in your list of tables. Then we also look at when we went on to look at the two popular methods to do fuzzy inference, which is your Mandani and your Sugeno. Then we spend some time looking at how we actually plan and design a system to actually advise you to keep how many spare parts should I keep when you're running a shop, factory, right? If you like a factory or a shop, workshop, right? Workshop to repair broken car parts. So at the end of the day, how do you ensure you keep your customers happy? So this was a case study on the fuzzy inference system for that application. Okay, so this is the one with this was on the we studied this in terms of we have three rules here. If X is A3 or Y is B1, then Z is C1. So this is your two inputs and one output. This is a Z. Rule number 2, if X is A2, this is your membership. Y is a B2, and then Z is C2. And finally, the rule 3, if X is A1 and Z is C3. So the membership graph are given as such. So your input Y and input X. So input Y has B1 and B2, right? These are the membership graph, right? For Y, B1 and B2. You can see there's a intersection, overlap between your B1 and B2 memberships. And then similarly, you have your X input. Now, X input has three membership functions, which is A1, A2, and A3. And also, this is tied back to here. So actually, we actually are able to solve this based on and of course, output of Z, C1, C2, and C3, based on the values given for you, right? If X is 91,000 and Y is 34, we want to calculate the output, the final crisp output for using the Mandani and using the Sugeno. And we can see that it took a lot of effort and time to actually calculate using Mandani. Whereas when you use Sugeno, right, the answer come around very fast, right? Because it's only easier to solve. But of course, the answers are quite different because your Sugeno, although it's very fast, accuracy is not there. It was seemed to be less accurate compared to the Mandani. So after that, after completing fuzzy logic, we then move on to learn about the artificial neural networks, or ANN for short. We look at some of the common architectures of your various types of artificial neural networks. and some of the main characteristics of your artificial neural networks. Now, one of the main characteristics of your artificial neural network is that it is basically consists of very simple processes. That's your summation and your non-linear transformation of the output of your summation transformed to the output. We also look at some of the history, the key milestones of your evolution of your artificial neural networks, and some of the key developments, among which is that we find that after a while there was some major criticism, right, of the field itself, and therefore the U.S. government stopped funding. And of course, once the U.S. government stopped funding, there's no money there, so people move on to do other things. So after a while, the artificial neural networks almost died out. And only after when the Professor John Hopfield and his colleague David Tang published some work on the Hopfield net, then only there was a major resurgence in the interest and also the funding of artificial neural networks. We then look at a simple example of the perceptron single neuron and how it learns. Right? This is a perceptron learning rule. So this is a tutorial on that. Then, because of the limitations of your what? Single perceptron, it's not able to separate non-linear search space. So therefore, the multi-layered neural networks was proposed as a solution to that. And then the multi-layered neural networks, one of the popular common learning method is your backpropagation learning algorithm. This one is taken from the tutorial, right? We actually spent some time looking at this and calculate what's the output of this. Okay, any questions so far? So after that, finished with the feed-forward type of neural network, we went on to look at the recurrent neural networks, right? And this one is another name for this is actually your neural networks with feedback. with feedback. Among the various types of recurrent neural networks is your Hopfield net. Then we actually spent some time looking at the two types of Hopfield net, which is the discrete and the continuous Hopfield net. So this is something we just finished, I think, last week and this week on the tutorial of that. And then we look at these two major applications of your Hopfield net. One of them is your, especially in the discrete model, this is your associative memory, right? So associative memory that even if you give a fragment, not a complete picture, not a complete pattern of your image, the Hopfield net was able to reconstruct back to give you the actual what is seen as a accurate, correct now. What is seen as a correct pattern, even though you keep it part of the picture, right? So, for example, I've talked about this before. When you see part of a face, a part of a picture, this Hopfield net is able to give you back the complete picture of what this picture is supposed to be. That is your discrete model. Now, in the case of your continuous model, we look at it to solve the traveling first person problem, right? And again, it was able to give you various types of answers. Of course, up to you to select the answers. And of course, one of the advantages is it's very fast compared if you try the brute force method. Right? This is your the tutorial on the recurrent Hopfield net. Right. Now, this is the one on the calculation for the connection weights of your continuous Hopfield net. Now, so that was the two models of Hopfield, the two models, which is your feed-forward type and your one, and the other one is your recurrent neural networks. Now, in the last 10 years or so, there was a big interest, among a big interest plus a major breakthrough in artificial neural networks, which is actually the deep learning, right? So deep neural nets. So we actually look at the introduction of deep learning and also what was the motivation and challenges of deep learning. Then we look at some of the common deep learning models, which is your convolutional neural net. And then we look at what is deep learning good at? What is it good at doing? Right? So we look at the deep learning for image processing, and also sound, audio signal processing. We look at this, and we look at the introduction to the convolution neural net, and then the pooling, dropout, and then applications of the CNN. Right, this is something we just completed this morning. Now, the other topic actually we went on to actually was on swarm intelligence. So, as usual, before we start a topic, we have to understand the definition for swarm intelligence. So, we actually spend some time to understand, to actually appreciate what you mean by swarm intelligence. What are the types of swarm intelligence we have? So we noticed that this came about because biologists and scientists observed that there is, for some insects, they actually exhibit social behavior. So then we went on to look at the two of the popular and quite powerful, useful, common swarm intelligence methods, which is your ant colony optimization, or ACO for short. Now, after the ants, we then Eberhard, right, and his colleagues noticed the flocking behavior in the birds. The birds actually come together, and then without one telling who's a leader, they will organize among themselves to lead the flock, lead the group of birds in flying, a certain formation. So as a result of this flocking behavior, they actually proposed the particle swarm optimization method, which is quite a powerful method. I can see that a lot of papers being published to show you that PSO, particle swarm optimization, can be used to solve some very difficult, challenging problems. Now, these two are only the what they call the more common and also established, right? The swarm intelligence. Of course, there are many others, right? And then we highlighted some of them: your cuckoo search, your bat algorithm, your your artificial bees optimization, right? No, artificial bee colony, right? ABC, and also there are others methods which actually comes under the umbrella of swarm intelligence. Right, so I think we spend an hour looking at how to solve this. If you have 4 particles in your PSO, how do you calculate its movement, right, as it searches for the largest value, right, largest value in this search space, in this problem space that it's trying to do, right? So this was the example given for us this was a case study for us to investigate how each of these particles will try to work together to find the highest point in this landscape. Right. Other than your PSO, we also spent some time looking at how the ACO will do the clustering. How does it organize data? So the same data will sit together. Different data will be separated from the majority of the particles in that space. So finally, the last topic that we actually look at was the support vector machines. Again, we look at the history and the motivation of the support vector machines, and we also look at some of the fundamental important mathematical foundations of support vector machines, which is, for example, the measure of a similarity between 2 vectors, and also spend some time looking at the kernels, the types of different kernels, and the feature space. Basically, because your support vector machine, or SVM, looks at this feature space and uses kernels to actually transform your non-separable lower dimension feature space to high dimension feature space that is now linearly separable, right? By using the technique called kernels to actually transform your lower dimension data into high dimension. Now, we also spend some time, a quick tour of the concept of classification versus clustering. And we look at the types of hyperplane, and then we actually spend some time to actually calculate how they actually calculate the hyperplane, the distance, and also what you mean by support vectors in your linear support vector machines. Right, this is what we have. on the when we have the data of male and female based on two features, right? Height and the weight. How can we then find out where is the optimal hyperplane, identify the support vectors on this same set of data, and then if someone has a height of 7 and 8, using the same hyperplane, we will then tell you whether it's a male or female. And we actually spend some time to calculate the distance of the support vectors to the appropriate hyperplane. Right, so this is now remember, the support vectors are those which are closest to your hyperplane, the actual hyperplane that separates the two classes of data. Right, so these are the, now to summarize, these are the, so this is actually, I think, the problem with the ordering. So 2, 4, 6, 7 key steps. First of all, you identify the appropriate support vectors. Of course, you need to also spend some time to actually, what I call it, plot the values into the graph paper, right? The so-called the feature space. And from there, it's easy for you to identify the appropriate support vectors. And then you form the equations for each vector, right? And then remember to add a bias. So once you identify the support vectors, you add a bias, right? The equation first, but then of course, don't forget to add the bias to each of these support vectors. And then you solve this to obtain the values of the constants, and then you calculate the weight of the hyperplane, which discriminate one class on the next. And then once you done that, you reorganize your equation of the hyperplane so that it fits into this general equation of a linear line, so that you can now use this equation here to calculate the orthogonal distance, the 90 degrees, the distance between this support vector, orthogonal distance to the hyperplane. Okay, so that was the quick tour revision of the 8 or 7 topics in this paper of artificial intelligence. Now, in summarizing, right? End of the day, we are here to learn. We are here to learn so that you can use the knowledge to do your job, right? And of course, it is a two-way process. I always keep saying that it's a two-way process. That means that, first of all, you must be willing to learn, right? And must be willing to learn. And now, of course, if you find that you're not learning, right, then you ask. You ask for clarification so that you learn, right? That's my job, to make sure you learn, and your job is to learn the knowledge. So as I said, it's a two-way process. I can't do it alone, so I need your help, right? If things you don't understand, I will try my best to clarify further. And of course, I think some of you actually use say a very wise word the other day. Sometimes you do not know what you do not know. The same applies to me. I do not know what you do not know, right? So I will try to, based on my experience and also my years of teaching, I will speculate, I will predict, I will estimate to see that this area you do not know. So I will try my best to explain in the best of my ability so that you can understand. Of course, it's not perfect. It's not perfect. There are some things that maybe I cannot explain very well. So it's up to you to actually ask for further clarifications. Now, the feedback through the years has always been difficult. It's difficult to understand, difficult to follow, difficult to learn. And some of you also say it's boring, right? Engineering is boring, mathematics is boring, AI is boring, right? But of course, because it's a bit, sometimes it's a bit dry, right? The topic itself, full of equations, full of words, so it's not like watching a movie. Of course, movie is exciting, right? But we do hear you. At least I do hear you. I do put effort to actually make it less boring, make it less difficult, right? How to do that? I'll come to that later on. So we do hear you. Not to say that we do not listen to you. We listen to you, right? So the question is, will it ever be easy to learn? Yes and no, right? It will not get any easy because you still need some efforts to learn. You need to put effort to learn, right? So it cannot be easy, right? Because if it's easy, everyone, you do not need to come here, right? You do not need to come to a university. You do not need to come to a college, right? So it's always going to be, it will not be easy, right? Of course, I use an example. Sweeping the floor is easy. I don't need to spend years, 4 or 5 years to learn how to sweep the floor. Maybe half an hour, I will be good enough. Even operate a vacuum cleaner to sweep the floor, right? So therefore, because it is not easy, that's why what? That's why very few people will have that honor, if I may say so, honor and the opportunity to become engineer. That's what you are, right? Or at least you will be in the next 6 months or so, right? 6 months or so, you'll be graduating, right? So once you graduate, pass all the papers, you'll be an engineer. So it will not be easier, right? Of course, you still need effort to learn. Of course, there's also a process whereby we try to take those at least qualified so that you will not be struggling in the past few years to learn the topic to become an engineer. And I think this is something also I talk about in the first introduction to this paper, right? In the old days, you learn by just following an expert, right? Following the mechanic, following the expert, right? But now, a lot of people want to be engineers. A lot of people want to be accountants, for that matter, as an example. So it is, it will not be easy because we never say it's easy, but of course, it's up to you to learn, right? So to learn to become good so that you can have a good life later on. On the same note, for this paper, we only cover the basics. Of course, there are many advanced areas, so we don't have the time to cover that. But of course, as I said before, the main thing here actually in the university for this paper and other papers is actually what? You look at it closely, we're actually here to teach you how to learn, that's it. So I think we also talked about this before. It's a lifelong learning. Some of you may have heard this before. That means that once you go out, you will still continue to learn. Why? Among other things, technology, especially technology, will continue to grow, continue to evolve. Things will change, right? But of course, the fundamental things, 1 + 1 = 2, will still remain. But based on that, I think I talked about this before. Maybe before 2016, for example, right? You never hear about deep learning. But now with deep learning, right? So everyone is actually, so the thing has shifted now to deep learning. Everyone want to learn about deep learning. I think I need to bring it here. I don't have it. I didn't bring it here. But in the old days, how do you do calculations? For the Chinese, the Chinese history, the Chinese culture, we have this abacus, whereby it's a calculator of some sort, right? In the old days, it's very good. But now we don't have that. Now we have this calculator, right? So and now, of course, you have your handphone. You can also have a calculator. And then, of course, you have your computer, right? So you have to continue to learn, which is back to this point here. So that you need to learn, especially to fit to a job, right? Now, what do we do? Right? So we hear you. It's a difficult subject. It's a boring subject, right? It's not easy to learn. Yes, we hear you. So what have I done? I have actually tried to inject some videos. Right? At least I know that all of us like to watch videos, watch a movie, right? So I try to show you some of the applications of the AI method or AI is trying to solve. But I also try to show you some of the video of the other lecturers to lecture on things like search on other areas, for example. But I find that it's still not that exciting. I think many of you want this to be exciting. So so it's not easier. But I also mix it with other than videos. I mix it with songs to show you that even when we talk about singing, the song itself talks about it's not easy to be. I'm only humans. Humans also make mistakes, right? So I'm trying to mix it up so that it won't be so boring. And of course, hopefully you will see why you need to study this, and also better understanding what is it. Humans make mistakes, so you also want to create a machine that will purposely make mistakes so that it is closer to become a human. Other than that, I also put in the effort to give you examples, talking about to explain to you simple things like apples, oranges, to actually classify how to extract the features, the concept of feature extraction, to actually use that to using AI to identify whether it is apple or orange, right? So this is, and of course, I'll try not to be too fast, right? So if I speak too fast, if I run through the top lecture very fast, half an hour pitch everything, I find that you have difficulty to understand. So I put effort to actually slowly ask you once in a while any questions you have, so that you can have a better understand and to learn. Because at the end of the day, whether this paper or other papers, you need to, maybe at some point you need to use the knowledge to do your job. Now this is especially very true for AI, because many of us feel that AI will be part of a society in the many years to come, right? Because at the end of the day, especially in the COVID-19 situation, right? Some of these things actually can be, AI can help to reduce the dependence on what? Dependence on cheap, low-skill, foreign labor, right? Some of you are looking at, I know that my students are looking at what? Defects detection. How do I identify defects, right? Based on a time series of data, and also on the image itself, on the typical image, on the dark surface. So here, can you tell me where are the defects? So with computer vision and also AI, I can replace a human operator to find such defects. So at least we believe that, many of us believe that AI will be very relevant, right? Especially when you start to work. Maybe not all of you will work in AI, but some of you may work in the area, and when now you actually will then use the knowledge. Of course, not all of the knowledge here, because these are just the basic. So maybe you go deeper into some of the AI methods for your job later on. So this is actually the whole concept. And I think one thing I want to just highlight to you is that it's not that we don't hear you. We hear you. Also, I was a student before, long time ago. Engineering is not easy, never easy, right? It's boring. Yes, I do believe it's boring. But again, how do I make it exciting to say 1 + 1 = 2, right? Of course, you can, if you have ideas to make it exciting, to explain, to teach me 1 + 1 = 2, for example, please give us a feedback. Now, in closing, so I think at sometime in the near future, you'll be asked to fill up the feedback form. So I hope that some of you actually, my goal is to actually have a higher percentage. It's quite high now, percentage of the students actually believe that the topic is well organized, is well structured and things like that. So I hope that maybe more of you can actually put in a few good words for me to like my lecture and things like that. Of course, I also welcome for you to tell me how can I make it less difficult and also less boring. So I welcome new ideas. So I tried my best to actually look at videos and songs and other things to help to actually make your journey to learn more comfortable and also useful for you. Now, with that, now let's turn our attention to the examination. Now, why do we need examination, right? Examination is actually, at least for me, is to examine your understanding of your subject. It's not a memory test. That's why I don't believe in that. It's not to test how well you memorize certain equations, how well you memorize certain dates, for example, right? Your sejarah, right? When did so and so come to Malaysia or Malaya? When was it? This event happened, right? It's not about that. That's why you're given what you're given. Oh, sorry, not run out of time. I can just stay on for a while. Run out of so things like that. So it will cover every topic. So please, if you can, do not skip any topic, because every topic can be examined, right? So the questions itself, I believe that all of you can pass if you can do some revision, right? But the questions will also differentiate those who know the subject well and those who do not. So if you know the subject very well, of course you score better. right? If you're not so well knowledgeable on that, you will not do very well in that. But of course, my thinking is that it would not, at least if you put effort to learn, you would, especially nowadays with that open book exam, you should be able to pass at least first thing. Now, the style is similar to what you've been exposed. So the style of the questions for the exam will be similar to what you have been exposed in the tutorials. Now, of course, how do you get high marks? High marks will be given to your ability to convince the marker or examiner you know your stuff. I've been saying that since from day one. You need to convince the examiner that you know your stuff. Now, I've sent you the declaration form online. Sorry, if you can complete the online form before next week, right? The form actually is, I think I sent to all of you, so you should have it in your inbox so that you do not have to sign the form again on the day of the exam, right? Now, some recommendation, right? So when you write your exam answers, the answers to the exam questions, those is example of a good exam script, right? Very clearly written, and I can see clearly, and there's also a camera from the handphone is very, very good. So the scanning is very good, right? So I can easily mark, and there's no confusion for your answer. Now, this is another example, right? So you can see clearly, although the answer is wrong, but you can see it's very clear. What about this, right? So you can see that it's very difficult for me to see what's the answer, right? First of all, it's very small. Your pen is not very black, not very dark. Maybe your camera also scanning is not so good. So try not to do this. So as I said before, maybe you want to try to clean your camera lens before you exam. And this applies to not only this paper, other papers as well. So that if you know your stuff and you, because of this technical problem, right, you cannot do well. So it's a shame, really, right? So you should also be fair to yourself. Try to clean the lens and make sure you have a dark pen to write clearly. Right? Now, how does the exam work for this paper? So we have your question one. Each question, there are 4 questions here. Each question will be released one at a time. And okay, I think it's after you finish time's up for the question 1, then you are supposed to, okay, you have about 7.5 minutes to upload the answer script to the system using a Google form, right? And then if you take too long, right, after the second question is released, right, you still have you can still submit your your answer, but then marks will be deducted, or marks may be deducted unless there were valid reason why you are delayed for that. Right? Don't stress yourself too much. So, but I think this is nothing new. I think the same applies to all the other papers. We follow the same system in the TAR you see here on the faculty. So if you delay too long, then of course marks will be, you may be downgraded to 0 if you submit your answer too late for some reason, some invalid reason. So once your answer is submitted, once the time's up, so you have this buffer before the next question will be released, right? So after that, you repeat the same process. So even though the exam itself is only 2.5 hours, I think you have about end of the day, you have basically another half an hour extra for all these extra things. So the question itself, the next question will not be released until after the 7.5 minutes is up for you to upload your question for that. And do not, I repeat, do not submit more than once. So submit more than once unless, again, as I said before, unless you have a very valid reason, right? The second answer script will not be accepted in most cases. So please make sure within this 7.5 minutes, you have you're sure you have the correct answer script to submit. And furthermore, even in these days, I still find students able to complete the questions very fast. So if you complete the question early, please check your answer. And then, of course, you can also try to submit earlier if you want to. But better to wait for the next question to be released before you can do the next question. That's how the system works over here. Now, recommendations, suggestions. So please use white A4 paper. Bring along the graph paper have some graph paper ready, and then of course have a calculator, right? Good pens are recommended. If you don't, if pencils are not encouraged, but of course, if you want, you can also use a dark pencil. So to mark, to actually maybe if you feel that you can also erase easily, use a dark pencil. So that's also maybe acceptable. Now, clean your camera lens to ensure good, clear images. Check your emails, Google Classroom to get updates. And if you want to do your examination elsewhere, for some of you, you might feel that your network is not stable, right? For those for you in maybe Kuala Lumpur, you might want to come to the campus and go to some corner to use the Wi-Fi, right? So you can also do that, but please apply to the faculty to say, I want to do my exam at the, I want to come into the campus to do the exam, at least we know. Now, ensure that suggested environment is available, so you have a stable internet and a good camera. So these are the things you should have to support your examination. Now, this is the, after I think this week or next week, latest, we will now close down the Google Classroom. And then the examination notice and everything will be done to this Google Classroom. Please sign in to that Google Classroom for you to actually do your exam. So I think that most of you, actually for 2 of you only, I think should qualify. So far, I don't see major problems in your attendance. I think attendance has closed already. So if you have not received any email from the faculty, that means that you should qualify to sit for your exam. Unless for some reason you are not allowed to sit for exam, which I'm not aware of. Okay, so with that, we have come to the end, and I think let me wish you good luck in your exam. Okay. In addition, most probably our path will not cross again since I'm not taking any other paper in your final year. So next semester, not be seeing you except for my FYP students. I think there's 3 of you. Right, 3 of you, isn't it? 3 of you. I think 3 of you, right? In this group. So I'll stop here. Sorry about that. I've taken about not too bad, about 10 minutes. Okay. So any questions before we dismiss?
Sir. Hello,
yes,
sir.
I think max pooling, yes, correct. Because normally you have small enough, so you do a max pooling. So max pooling, basically, if you don't do zero padding, you miss out that bit of information, right? So the most common one will be padding, doing a zero padding, right? The next good question.
Hello, sir.
Don't forget this one and also your feedback form. So I'm hoping that at least this year I will get a very high score. I'm aiming every year. I'm aiming to push the thing higher and higher. So maybe one day I'll get 100%, right? High score. Yes, Rian. I don't see a problem. But maybe not. I think faculty have not advised me. Faculty have not said whether we can do an iPad. So let me check on that. So far, I think no. I think they want, you see, an iPad unless you have a timestamp. So I think they also want the actual proof in case there are some what I call that argument, controversy over your exam answers. Right. So I think I would not try to, but again, this is something new for me. I don't know. I have to come back to you. Yeah, I know. I know what you're saying. It's written one, not typed. But again, I'm not sure because I think there's no no advice from the faculty, right? Yeah, iPad is it? So I think should be okay. Because I've seen, because my problem is correct. That's the thing. Check on the timestamp and the hashtag. That's correct. That's why I think it should be possible. Let me check on that. I need to check that because for the past 2 rounds, students have been using paper and graph paper, right? the current, I think I'll keep another week. I think your exam on the 6th of October, right? So I think it will be at least after today, I'll need to upload a few things. Upload the, what do you call it? Also need to check your signature for this declaration for your exam. And then I also need to upload the last lecture on the support vector machines, which are not uploaded. So it will be another week or so, easily. Lawrence, okay? Any more questions? Please ask, so that as I can see, this can force you in the face-to-face meeting to face-to-face class to ask you questions, to ask questions, not anything else. So again, you can see. Anything else? My voice is almost gone. You can see my voice is actually coarse already. If not, all the best, as I said before. That's why. Do you speak? Let me see. Try again. Try.
Hello, sir.
Oh,
now can hear.
wait.
Huh?
I can hear you on my other system, but not on my headphone. Maybe kaput here. Yes, please. Can find.
No, I asked already the question whether it can. Can be answered.
Understand.
Yeah.
So basically, what I'm trying to say is also maybe some of you may not be convinced, but I hope that the majority are convinced. AI is one of the new things that you will experience and you come across in your working life, right? So it's okay. Some of you may not be good at theory, but when you go out to work, you may be working with AI. Of course, when you say you have some knowledge of AI, you might give you a slight advantage when applying for a job, right? Okay. So actually, for me, I think I've shown you before some of the things that students have talked about feedback, in terms of feedback, right? That here, right? Find difficult, find boring. On my side, this is your wish list. Some of you hope that the lectures will be easy. The lectures will be exciting. But what about from the lecturer's point of view? For me, I would like to get more communication, two-way communication, right? So you can see I've been trying for the whole semester, trying to get many of you to ask questions. Because as I said before, I do not know what you do not know, right? So, but I also understand, maybe many of you are busy. And also, I think like myself last time when I was a student, you don't revise until last minute. But again, hopefully during the lecture itself, if I say some certain things which doesn't make sense to you, at least you will try. I hope that you try to ask me so that I can also try to improve myself, so that I will now know more about what you do not know. See that? Okay. So I think I see the numbers are still here. Last numbers are still here. Anything else before I go off? Ken, what is it? Yongxing? Wait. Let me try this. Maybe this I need to connect back my headphone. Tutorial 6. Can I have it? I think it's here, isn't it? Tutorial 6, maybe it's here. I think tutorial 6 will be your HopUnet, right? This is it. Question 2. Wait, I don't have it. Let me see if I can find it now. Okay, let me shut this down. Wait. Let me bring up your tutorial 6. I don't have it. It's a Hokkien net, right? Dongxing. Yeah, correct. Continuous, okay. That one is actually, if I'm not mistaken, it's quite straightforward. You have to know the equation and just put the values. Okay. Right. Okay. Okay. Answers are given here, right? Let me see. I can bring it up. Okay, how's this? Yep, sounds right. So this is you're supposed to design the network for this. Show the network, right? Answer here. So this is a 4x4 city. You need to have the same. Basically, it's like this, right? You can see this. So what's the question? Maybe you're speaking, is it? I can't. This is actually. No, the equation, I think it's given here. I need to go back to the side. So I think it's not question 2. I think it's question. Okay, question 2. Correct. Here. Sorry. Okay, for a while. There you go. I call it here. Sorry, I think I'm getting feedback here. I don't have my headphones not working and the headphones working, so I'll get here. Right. So we have this. Right. So I'm supposed to calculate the weight, is it? Let me try the answer. The question rather, not the answer. Wait a minute now. It's painful. My ear is painful already for 2 hours having the headphones. Tutorial 6. Okay, got it. Okay, right. So you have okay. Now what is this one, right? So if you look at the first one, you look at let's see the question. BC. The question is you try to calculate. Yeah. So B and C, right? So B and C. So we try to calculate the neuron pair 2 and 2, 2 and 3, and 2 and 4 for city pair BC. So you have your okay, then I can just show it to here. I show it back to this one. Turn on my this one. Okay. Now your weights. First calculate the weights, right? 2, 3, B2, B. Okay, now two things here. And so here, so we have your 1, 2, 3, and then we see. Okay, so we have your control here. Let's try one. Oh, sorry. So we have your weight now. So we have your weight. So the first one is actually here. Your weight for your CTB neuron 2, right? 2, 2. So your maybe I'll do the other way. So this is C3. Here, let's try this pair. Right, 2 and 3, right? 2 and 3, B and C equals to. Now, what's the equation? For the equation, okay, the equation is minus alpha 1 is your delta xy, 1 minus delta xy minus alpha 2 delta, I see that. This will be ij, right? And 1 minus delta ij, no, right, this is xy. This is correct. Mistake. Sorry, this is my delta ij. This is my delta xy minus alpha 3 minus alpha 4 dxy into this one here. I'll write down here. I can continue here, right? Minus alpha 4 dxy multiply into delta. This is j. I plus 1 plus delta j I minus 1. Correct. Okay, so I'm looking at this pair. Now, the thing is that these alphas are all given, right? So now, if I will substitute, now what's x and y? X and y will be your BC, right? BC. So here, my delta BC equals to what? Equals to, because you look at the canonical delta function, if they are not the same, it will be 0. So if you have a delta, say BB, right, equals to 1. So this is your canonical delta function, right? So sorry, I can't see you guys already. I'm looking at the question paper and then looking at the answers. So this is this. So we have this here. Now, so if my B and C is x and y, so I B, and then the 2 and 3. So in this case will be delta. This will be 3 and 2 and 3, right? So this is bar. Again, 2, 3, ij. So this will be right. So j is 3, 3 and 3, right? Plus delta 3 and 1, right? Because I is 2, 2 minus 1 will be 1. 2 plus 1 is 2. So in this case, you get a what? So as I said, if it's say PQ or PP equals to 1, delta PQ equals to 0. If it's not the same, if it's 0, it's the same with 1. Right? This is our canonical delta function. So therefore, you just substitute values inside, right? So we have it here. So this one becomes for 2 and 3. I'm just trying for 2 and 3. So I have now your here alpha 1, alpha 2, alpha 3, your alpha 4, n. Okay, so your question is here, right? So first one is what? Alpha 1 is 500, 500, 200. So write down the alpha first, equals to minus 500 into xy. Xy is BC. BC will be 0, right? So this will be 0 multiplied by 1 minus 2, 3. 2, 3 will also be 0, right? Because it's 2 and 3, right? 2 and 3. And the next one will be minus alpha 2, also 500. Now the xy, ij will also be 0, right? This is 2 and 3. Then your 1 minus bc, also 0. Then your alpha 300, right? The last one is here, alpha 4. Alpha 4 is what? Alpha 4 is 500 also, right? So 500. So therefore you have a 500 into, now 3 will be a 1. Oh, sorry. Before that, I missed out another one. My distance here, dxy. Now dxy will what? Dxy will be, xy is bc, isn't it? bc is a 5, right? Distance is a 5 times 5 into 1 plus 0. So what I get? This is 0, 0. Over here it equals to minus 100 minus 2005. So you get your minus 2006 for that second case, 2, 3. Do the same thing for 2, 2 and 2, 4. Let me come back to you. Any questions so far? Yongxin. Okay, so you try the 2, 4 and 2, 2. Okay, so I think I will go with it. I will go washroom, 2 hours. Okay, bye-bye.
Tomorrow.